Welcome. Thank you for joining me for 4-6C. So we're still working on completing the square. Today we're going to learn a different way to use it, okay? But before we learn a different way to use it, I do want to take the moment to review how did we use it yesterday. So remember, this idea of completing the square is if we can get it to be a perfect square trinomial, so get two of the same factors, that's how we use this process. And one of the conditions of that is there can be no coefficient with the x squared. So if there's ever anything with that x squared, and remember we want to do away with it first. So here my first step would be, let's divide everything by -1 so the x squared can have no coefficient. It can just be alone, okay? Second thing, I always move the constant over, okay? So I'm going to add that 16 over because ultimately what we're looking for is we're looking to add something to both sides so this thing right over here can factor into two of the same parentheses, okay? So let's start working through what that would look like. So the x squared obviously comes from x and x. The 4x, remember that comes from these two connections right here. And the only way to get two of the same thing is if it splits itself in half. It splits itself up between the two because that's where you end up with 2x plus 2x giving you the 4x. Then the really special connection here comes from right there. That connection, so 2 times 2 giving me 4. That connection tells me what that magic number was that I was adding to both sides to make this process even possible. So on the other side, I'm getting 20. So what does that leave me with? Well, it leaves me with x plus 2 quantity squared equaling 20. Okay, I'm going to come over here now so because I need some more space. So right now we're sitting right there. And of course, the next thing we've been doing for days, I started to think about this next piece days ago to make sure that you got good practice on it. Because that whole side of the equation is being squared, I'm going to square root it. So I get x plus 2 and then plus or minus square root of 20. Remember, that's not a nice value, but that's okay because remember, I taught you a way to think about this. Okay, so I taught you that you can break that down. 20 breaks down into 4 times 5, and the reason that that is critical is because square root of 4 is simply the number 2. Then, of course, I still have that x plus 2 over here. So if I want to know specifically what x is, well, x, I just have to subtract 2 over, leave everything that was already there, and there is my solution, okay? Not the prettiest thing ever, however, nonetheless is the solution to that equation. All right, so now looking through here, we can do this, okay? So now what if I want to rewrite that equation? I want to rewrite that equation so I can put it in vertex form because right now this is standard form. And let's say I want vertex form, okay? So what am I going to do? Well, what I'm going to do is, again, I'm going to isolate this, okay? Because remember, that is the essential part. So step 1 is realizing, so I have this x squared plus 10x plus something that is going to let me factor that nicely, okay? And that plus is something, again, has to go on both sides. Okay, so the first thing I'm going to do is figure out what is that something. Remember, that's what this represents. And I didn't make you memorize that because I've always shown you another way. But remember, b over 2 squared really is that number that I'm searching for. Okay, but if you're not good at memorizing that, again, you can always think to yourself, all right, how is this going to factor? Well, the x times x will give me the x squared. That 10, that 10 has to split itself up evenly to get 5x and 5x to get the 10x. So it splits itself up evenly to get that. And that number that I had to add to both, that comes from this final connection right here. 5 times 5 giving me 25. All right, so what does that look like? Well, it looks like this. So now I have x plus 5 squared. And then notice I still have that minus 1 at the end. I haven't done anything with that value yet. Okay, and that's fine. Because now, to write it as an actual equation, now we need to get the y by itself. So now I'm going to subtract off that 25. And that is where that negative 1 finally does something, okay? When I subtract that number back over, that is where that comes in handy. And this is what that equation would look like in vertex form. All right. So let's get a little bit more practice with this, shall we? So again, the goal here, the ultimate goal is to figure out what am I adding to both sides to make this possible. So that x squared minus 8x, it's going to have something I add to it to make that a perfect square trinomial. And then right now, I just really don't care about that 3, okay? That constant that's already there, I just kind of set off to the side for later because I care about those x's. Because I need to figure out how can I get these to be two of the same thing? Well, x and x, obviously, to get that x squared. But then that negative 8x, it has to split itself in half in order for those to become the same parenthesis. So negative 4x minus 4x is where that negative 8x comes from. And now this connection right here, that is a special connection that tells me what I'm adding to both sides. Okay, that's that b divided by 2 squared value that we needed. So now I'm right here in my process. I have the x minus 4 quantity squared. This is where finally that 3 is going to do something. Because now to get the y by itself, I'm going to subtract that off. And get this as my solution. All right, and the next one, again, exact same process. Okay, I want to know what I'm adding to both sides to make this process work. So I need to know what am I adding inside there. And right now my 7 really isn't going to play a role. Okay, right now the 7 just kind of has to be there. Okay, the key is figuring out how does this thing break down. Well, the x squared comes from x and x. Remember that negative 6x, that negative 6 has to split itself in half to make these the same factor. So negative 3x minus 3x, that's where that negative 6 is coming from. And finally, this last connection right here, that is what I have to add to both sides. So where am I at? Well, right now I have that x minus 3 squared because I had a 2 of the same factor. And now finally, this is where that 7 is finally going to do something useful for us. We subtract 9 from both sides, and we get that. All right, now remember, I'm always a fan of you being able to check your work before you ever hand me your test, right? So I want to explore with you. There actually is a way you can check your work here, okay? So take out your graphing calculator for me, please, okay? And for this last one, I am going to graph that equation. X squared minus 6x plus 7. All right, so let's graph that. So that's my original equation, right? And now I've transformed that equation into something else, okay? I've transformed it to look like this. X minus 3 squared minus 2, okay? So what I want you to think about is if I put the equation I started with and I put my end result, if I have the right answer, I'm hoping that you can recognize the idea that they should give me two of the same graph. And look, they have. So that's a really powerful tool on your test to check to make sure you've done this right, okay? Because if you graph them on top of each other, they should overlay perfectly. That is an amazing way to check that you have the right answer, okay? Take your equations, graph them both because they should give you exactly the same value when you do so. Okay, so now let's do a more complicated one. All right, let's do a challenge like this. So this one, the first thing that I'm hoping that you realize is notice this 2 right here. And remember, when we're doing the completing the square process, we really don't like having that 2 there, okay? So what I would implore you to do is let's divide everything by 2. Okay, so boom. Now that 2 isn't an issue anymore. Okay, I divided everything on both sides of my equation by 2. So now that x squared isn't, or now that 2 isn't a problem. So now my goal is going to be the same. Let's find what I need to add on both sides so I can make this process work. Okay, and of course, what we're looking for is here, x times x to give me the x squared. That negative 4, it has to split itself evenly between those two connections. So I get 2 of the same parenthesis. Then that final connection comes from that. All right, so where are we sitting now? Well, right now, we're sitting like this. Now the only difference here, the only difference is now I have 2 more steps to complete before y can finally be by itself, okay? I need to subtract the 4, and I have to multiply everything by 2, okay? And when I multiply everything by 2, all it does, it multiplies the outside of this thing, and it multiplies the constant at the end. Notice it left the inside alone because you wouldn't multiply the 2 everywhere. That 2 I'm just going to leave out front. Okay, just like that. So that's how you can still do this process even when the x squared has a coefficient with it. Okay, divide the coefficient off, do what you need to do, and then in the end you just have to be careful with getting the y back by itself again. All right, so again, another day of really good stuff, and I hope it was also a review of what I had you do yesterday to solidify that idea of how to complete the square. So again, thank you so much for joining me, and please make sure you write that summary and then come back ready to do your practice work.